This video is purely for educational purpose. The content in this video is a part of the book NIRFA Mathematics. All students and teachers who read and refer the book NIRFA Mathematics can enjoy this video fabulously. It's an advice to solve all exercises in the book after watching this video.
Hello and welcome. Dear students, today we are going to discuss extremely useful method in mathematics. But before that, I would like to ask a very interesting question to all of you. Dear students, do you know how to tie a shoelace? If yes, then wow, you are awesome. But if not, then you must know how to do it. For that, please watch this short video. Well, now you would be thinking that why this professor of mathematics is discussing about tying a shoelace. Is there any connection between the shoelace and mathematics? And the answer is yes. There is a connection between the shoelace and mathematics. Do watch complete video. You will get surprised at the end. Now, I will be asking some questions. Please try for their answers. So, first question is, can you find area of this triangle? This triangle is having one of the angle is 90 degree. This side is of length 4 and this side is of length 8. So this is a right triangle whose base is 4 and whose height is 8. And therefore, we have to use this formula to get the area of such a right triangle. And what is the formula? Area is equal to 1/2 base into height. What is the base? 4. Now I am just putting the values of base and height. Then I will get 1/2 into 4 into 8. So 2 1s are 2, 2 2s are 4. This 2 1s are 2, 2 2s are 4. I will get 2 8s are 16. So the answer is 16 square units. Wow, excellent. Now, which type of triangle is it? Since the sides of these triangles are equal and their length is 5, therefore it is called as an equilateral triangle, right? Then how to find the area of such a triangle? And the special formula for equilateral triangle is area of equilateral triangle is equal to √3 divided by 4 times square of side. So what is the side of this triangle? 5. Therefore, its area is √3 upon 4 square of 5, and we know that square of 5 is 25. Therefore, its area is √3 upon 4 into 25 square units. Good. Now, see this triangle. Can you find the area of this triangle? Now situation is different. This triangle is not a right triangle. This is not an equilateral triangle. Therefore, whatever the data provided by them, using that only we have to find the area of this triangle. So what is given? One side is 4 and another side's length is 10. And the angle is also given in between these two given sides, that is 30 degree. So which formula will be helpful to find the area of this triangle. And formula is 1 by 2 into product of two given sides. So 4 is given, 10 is given. So take its a product, and sine is a trigonometric function, sine of angle between these two given sides, and it is 30 degree. Therefore, the formula is 1 by 2 product of sides and into sine of angle between these two given sides. We know that the value of sine 30 degree is 1 by 2. Therefore, area is equal to 1 by 2, 10 into 4 into 1 by 2. After simplification, this 2 into 2, 4, and this 4 ones are 4. So, we are getting 10. Therefore, area of this triangle is 10 square units. That's nice. Now, again, I am giving you one triangle, but the situation is different. Here, the sides, length of sides are given. We don't know whether it is a right triangle or not, and obviously it is not an equilateral triangle. Then the question arises, how to find the area of such a triangle whose sides are known. So, if we remember in our school, there is one formula called as a Heron's formula. And this formula will help us to get the area of such a triangle whose sides are given. So what is the formula? To use that formula, first of all, find the perimeter. The perimeter means the sum of all the sides, that is 4 plus 8 plus 6 and divided by 2. So it is a semi-perimeter denoted by S. What will be the value of S? So it is 12, 12 plus 6, 18 upon 2, that is 9. So value of semi-perimeter of this triangle is 9. Now what is the formula? Area is equal to under root S into S minus 1 of the side into S minus second side into S minus third side of that triangle. So your sides are given, therefore we can write S, the value of S is 9, therefore it is equal to square root 9 into 9 minus 4 into 9 minus 6 into 9 minus 8. And after simplification, we are getting under root 9 into 5 into 3 into 1. We can easily find out the square root of 9, and its square root is 3, and therefore our required answer is 3 under root 15, or we can say that 3 under root 5 into 3 square units. This is area of this triangle. Now the interesting thing is, now I am giving you again one triangle, but here the situation is again different. Instead of giving sides or angles, the information is only given that are the vertices and their coordinates. So triangle has 3 vertices. We already know. We are giving the name. This is vertex A, this is vertex B, and suppose this is vertex C. And we know all the coordinates of these vertices A, B, C. Then how to get the area of such a triangle? So for this task, if we know how to find the distance between 2 points, then if I want to find distance between AB, there is a distance formula in the coordinate geometry, that is square root first coordinate of A minus first coordinate of B, take its square, plus second coordinate of A minus second coordinate of B and take its square. So this is 2 minus 2, 0, square of 0 is 0, 3 minus 5 is minus 2, and the square of minus 2 is 4. And its root is 4. Actually it is plus minus 4, but we are considering distance, and distance never negative. That's why we are considering its absolute value, that is 2. So the distance of side AB is 2. In the similar way, we can find the distance of AC, also distance of BC. And after that, once we got all the lengths of the sides, then we can use which formula? Heron's formula. And after that, we will get the area of this triangle. So that means we have to do a lot of calculations to get the area of this triangle. But now, I would like to recommend one method that is called as a shoelace method. And using this method, we can find the area of such a triangle easily. How to get this? Just see. So, this is again, I'm considering the same triangle and I'm using the shoelace method. So, what we are doing in this method, how many vertices we have? 3, right? Because it is a triangle. Now, add 1 in that number of vertices. We will get 4. So, you draw 4 pair of holes. These are the holes. You have to draw 4 pairs. If you are solving for a rectangle, then rectangle is having 4 vertices. That's why you have to draw 5 pair of these holes. So these are the holes in which we are tying the lace. How to tie lace? You start from this hole, you go here, then here, then here. Then you attach with this and then go like this, and like this. So this is the way how to tie the lace in shoe. So this line, and this line are parallel. So these 3 lines are parallel and these 3 lines are also parallel. So another parallel line set I'm denoting by double bond like this. So the lines which are marked as a double line, they all are parallel and single lines are also parallel. Now what I'm doing, so give number label to this point, this vertex as a 1, and in the anti-clockwise direction you label the remaining vertices. So it is 2 and it is 3. Okay. So what are the coordinates of point 1? That is 2 and 3. You write 2 here and 3 here. X coordinate in the first hole and Y coordinate in the second hole. The second point is having coordinates 2 and 5. So you write 2 here, 5 here. Okay. Now third is 3, 7. So you write 3 here, 7 here. And now again you write the coordinate of first point. That is 2 as well as 3. Now what you are doing, this is a line parallel, 3 lines are parallel. So you multiply these 2 numbers. So what is the multiplication? This is 2 into 5 is 10 plus, again take a multiplication of these 2 numbers, that is 14 plus this multiplication is 9. What will the answer? The answer is 33. Okay, alright. Now you consider another parallel lines which are denoted by double bond. So construct a bracket for this. 3 into 2, 3 2s are 6 plus 5 into 3, 15 plus 7 into 2, 14. Now you calculate or simplify this. This is I think 21 plus 14, 35. You will get 2 values. One is 33 and another is 35. Now how to get the area by using shoelace method? So area is equal to 1 by 2, the value of first bracket minus value of second bracket. The value of first bracket is 33, the value of second bracket is 35. Make the subtraction, that is minus 2. Minus 2 upon 2 is minus 1. But area never negative, therefore we can consider its absolute value, and therefore the area of this triangle is 1 square units. How simple. So is it applicable only for triangles? No. This method is applicable to any polygon. So let's verify. We will see this is a coordinate system. For the sake of simplicity, we are considering rectangle whose coordinates are like this. So So this is the origin, this is a x coordinate, that is 6, therefore the length is 6, and this y coordinate length is 3, therefore breadth is 3. So we can easily find out area of this rectangle. So what is the area of rectangle? We know that traditionally the formula of area of rectangle, this rectangle is length into breadth. Okay, so what is the length? Tell me. 6. And what is the breadth? That is 3. And therefore the answer of this area is 18 square units. Now we will verify this area, the area of this rectangle, by using our new method that is called as a shoelace method. So let us see what is that method. So the previous figure was a rectangle and it has how many vertices? 4. Therefore how many pairs you have to draw? 5. So we can draw like this. This is one pair, second pair, third, fourth and fifth. Your first point is 0, 0. This is first, this is second, this is third, and this is fourth. And again, this is fifth. Okay, so we can write this is 0, 0. This is 6, 0. This is, I think, 6, 3. This is 0, 3. And again we write the same pair which we have written in the first. That is 0, 0. Right? Now you tie the shoelace. What is the procedure? Like this, like this, like this, like this, and after that like this, like, and like. All right. So this line is parallel to this line. This line is parallel to this line. This line is parallel to this line. Okay. Now remaining pair we can show by double bond to avoid the confusion only, like this, and like this. All right. Now what will be the value of first bracket? So how to write the first bracket? So 0 into 0, that is 0, plus this line 6 into 3, 6 3s are 18, plus this again 6 3s are 18, plus this is 0 into 0, 0. So 18 plus 18, 36. This is the value of first bracket. Now I'm calculating second bracket. So these parallel lines we are considering for that second bracket value. 0 into 6, that is 0, plus 0 into 6, again 0, plus 3 into 0, it is again 0, and 3 into 0 is again 0. All values are 0. So sum of all zeros are 0. So value of second bracket is 0. Now what is the formula? Area is equal to 1 by 2. First bracket value minus second bracket value. The first bracket value is 36 and the second is 0, and therefore 2 1s are 2, 2 8s are 16. So I got this 18 square units. So same answer I am getting by using this method also. So now the problem is, see, this is a rhombus. Now to get the area of such a rhombus when the vertices are provided, this is not an easy task. So you have to calculate the length of side and then diagonal, then use the respective formula of area of rhombus, and then you will get the area. But using our formula, what we should do? Tell me, how many vertices? 4. So how many pairs we have to draw? 5. 1 extra. So it is first pair, it is second, it is third, it is fourth, and it is fifth. So this is the first point vertex, this is second, this is third, and this is fourth. So first vertex coordinates are 3, 2, second 2, 5, third is -2 and 4, fourth is 1 and 4, and lastly we repeat the again same coordinates which we have written in the first pair, that is 3 and 2. Now tie the shoelace like this, like this, like this, like this. It's very interesting. Then like this, like this, like this, like this. Now this is parallel to this 1, 2, 3 and 4. Okay. Now I am joining this parallel to this one, parallel to this, and this parallel. 4 parallel lines. So I am calculating first bracket. 3 into 5, 15 plus 2 into 4, 8 plus this is minus 8 plus 1 into 2, 2. So 15 plus 8, 23, 23 plus 2, 25, 25 minus 8, that is 17. Alright. So let us calculate second bracket. Now I am considering the another pair of lines. 2 into 2, that is 4, plus 5 into minus 2, that is minus 10, plus 4 into 1, that is 4, plus this is 4 into 3, 12. The answer is 4 minus 10 minus 6, minus 6 plus 4 minus 2, minus 2 plus 12, that is 10. So second bracket's value is 10. Now according to Shoelace formula, area is equal to 1 by 2 first bracket value minus second bracket value. This is 7 by 2 square units. This is the area of this rhombus. Okay. Now this is a really master stroke because this is now a polygon with how many sides? Can you calculate? 1, 2, 3, 4, 5 sides. And this is not a regular pentagon. Then if anybody asks what will be the area of such a figure, then you have to cut this figure into triangles or quadrilaterals which will give us separate area and then add them. Then you will get the total area of this figure. But instead of doing such a things which are very lengthy, what we are doing, we are using our Shoelace formula. So for that we have to know what are the coordinates. So these are the coordinates. I am just changing the ink of pen. So what should I write? Red. Okay. So this point is having coordinates, see 3 as a x coordinate and 4 as a y coordinate. So 3, 4. This point is having 5 as x coordinate and 6 as a y coordinate. This point is having 9 as a first coordinate and 5 as a second coordinate. This point is having 12 as a x coordinate and 8 as a second coordinate. And this point, last point, is having 5 as a first coordinate and 11 as a y coordinate. 11. Okay. All right. Now, using this, I'm giving, you have to take all the vertices in a proper sequence. So this is 1, this is 2, this is 3, this is 4, this is 5, this is again 6. So use either clockwise direction to give the nomenclature of the points, or you may use clockwise direction also. So okay, now I'm using Shoelace formula. So what is that? So how many vertices we have in this figure? 1, 2, 3, 4, 5. So how many pairs we have to draw? 6. All right. First pair, second, third one, fourth, fifth, and sixth. The coordinates of first points are 3, 4. Okay. Second, 5, 6. You write like this. Third is 9 and 5. Fourth is 12 and 8. Fifth is 5 and 11. And in this last pair, you have to write again those coordinates which we have written in the first pair. Sorry. These are 3 and 4. Now tie the lace. This is very interesting part. Like this. Oh, good. Now these parallel lines I am showing by double bond to avoid the confusion, like this. Okay. Now I am ready to calculate the value of first bracket. So these parallel lines joining the holes, and we can multiply these numbers and add them. So 3 into 6, that is 18, plus 5 into 5, that is 25, plus again 9 into 8, that is 72, plus 12 into 11, I think 12 tens are 120 and 112, that is 132, plus the last one is 5 fours are 20. First of all, we will add it. So this addition is 43, and it is 45, 115, and this 20, 135. 135 plus 132, so that is 267. Okay. Now the second bracket I am calculating using these double bonds. 4 into 5, that is 20, plus 6 into 9, that is how much? 54. Okay. 5 into 12, that is 60, plus 8 5s are 40, plus 11 3s are 33. Now what is the addition? That is 74 plus 60, that is 134, 174, is it okay? 174 plus 33. So this is 207. We can write 207. Now tell me, what is the formula of our area? Area is equal to 1 by 2 value of first bracket minus value of second bracket. Okay, so it is 267 minus 207. I'll be getting something 60. Its subtraction is 60. Therefore, we can write this as 1 by 2, 60, and 60 divided by 2 is 30. So the area of that polygon is 30 square units. So this is the way we can calculate the area of any polygon using this method. So this formula is described by Master in 1769, and this is a particular case of Green's theorem. Please share and subscribe and try to read NIRFA Mathematics books. Thank you.